Welcome to this tutorial on the CIDRmatch command in Splunk SPL. The CIDRmatch command is a powerful function used for IP address range matching. It allows you to match IP addresses against CIDR notation ranges, which is essential for network analysis and security monitoring. CIDR stands for classless interdomain routing, and it's a method for describing IP address ranges using a slash notation. This command is particularly useful when you need to categorize network traffic, identify internal versus external connections, or perform security analysis on your network data. The CIDRmatch function is designed to determine whether an IP address falls within a specified CIDR block range. Think of it as a way to ask the question, does this specific IP address belong to this particular network segment? The function returns a Boolean value, either true or false, making it perfect for filtering and categorization tasks. Its primary purpose is network security analysis and IP categorization. You can use it to identify which network segment an IP address belongs to, whether traffic is coming from internal or external sources, or to filter logs based on specific network ranges. The basic syntax of the CIDRmatch function is straightforward. You write CIDRmatch followed by parentheses containing two parameters. The first parameter is the CIDR block, which should be enclosed in quotes. This represents the network range you want to check against. The second parameter is the IP field, which is the field in your data that contains the IP addresses you want to test. For example, if you want to check if IP addresses in the source IP field match the network range 192.168.0/24, you would write CIDRmatch with the CIDR block in quotes, followed by the field name. Let's look at a practical example of how to use CIDRmatch. In this example, we're using the eval command to create a new field called as _internal. We use CIDRmatch to check if the source IP addresses fall within the 192.168.1.0/24 subnet. This is a common private IP range used in local networks. The result is stored in the _internal field as either true or false. Then we use the where command to filter our results, showing only the events where _internal equals true. This approach helps you identify traffic that originates from your internal network segment. When working with multiple network segments, you can use CIDRmatch within a case statement to categorize IP addresses into different network types. In this example, we're creating a field called network_type that assigns labels based on which CIDR range the IP address matches. First, we check if the source IP matches 10.0.0.0/8, which is typically used for corporate networks, and assign the label corporate. Next, we check for 192.168.0.0/16, which covers a broader range of internal addresses, and assign the label internal. Finally, we use 1=1 as a catch-all condition for any IP addresses that don't match the previous ranges, labeling them as external. This technique allows you to efficiently categorize network traffic based on IP address ranges. The CIDRmatch command has several common use cases in network analysis and security monitoring. For security analysis, you can identify traffic originating from suspicious or known malicious IP ranges, helping you detect potential threats or unauthorized access attempts. Network segmentation is another key use case, where you categorize traffic by different network zones such as DMZ, internal corporate networks, or guest networks. Traffic classification allows you to separate internal versus external traffic, which is crucial for understanding data flow patterns and security posture. Finally, compliance monitoring helps you track access from specific geographic regions or network ranges, ensuring that your systems meet regulatory requirements and access control policies. To optimize the performance of your CIDRmatch queries, there are two key strategies to keep in mind. First, use early filtering by applying CIDRmatch after where clauses to reduce the dataset size before performing the IP range matching. This approach minimizes the number of events that need to be processed, significantly improving query performance, especially when dealing with large datasets. Second, Optimize your CIDR ranges by using broader ranges when possible to minimize the number of function calls. Instead of checking multiple specific subnets, consider using a single broader range that encompasses all the IP addresses you need to match. These optimization techniques will help your queries run faster and consume fewer system resources. Let's summarize the key points about the CIDRmatch command. First, CIDRmatch enables IP range matching for network security analysis, making it an essential tool for anyone working with network data in Splunk. It allows you to efficiently determine whether IP addresses belong to specific network ranges using CIDR notation. Second, this command is essential for categorizing traffic and identifying network segments, whether you're distinguishing between internal and external traffic, identifying different network zones, or performing security analysis. Mastering the CIDRmatch command will significantly enhance your ability to perform effective network analysis in Splunk SPL, giving you the tools needed to understand network traffic patterns, identify security threats, and maintain proper network segmentation. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.